Welcome, ladies and gentlemen, and there we go. There's my slide. That's what I was looking for. So let me get my pen and change the color to blue. And let's see, make sure. There we are. So what we're going to do today is talk about numbers, how to handle numbers. And the reason why we're doing this is to make sure you understand why we do the things we do when we're talking about data. A little bit about uncertainty, why we do the things we do, basically. And so we're going to talk, first thing we're going to talk about are significant digits. And basically, significant digits means the numbers that mean something. So in short, these are numbers that mean something. Whoops, I forgot my eye. And so what we're looking for this is that you notice that all these, anything from 1 to 9 is significant if we have some data. And what we have here is that we have an example that we have 4 significant digits. 1, 2, 3, 4. 1, 2, 3, 4. Now on this, I want to make sure you understand that when we say 4 significant digits, we do not mean 4 decimal places. As you notice, this one does have 4 decimal places, but this one only has 1. 3,351. All 4 of these are significant, but there's no decimal place. So when you have some data, this means that if a scientist gives you data, it's saying that all these numbers are significant. Now there is a time where a number cannot be significant, and that's going to be 0. And it's ambiguity because depending on how we write that 0 and how we use the 0, it could be significant or insignificant. And it plays where it is on the period on how we write the number. So for numbers less than 1, if the 0 is to the left of the first non-zero digit, it's insignificant. So you see these 4 in red, they don't mean anything. They're not significant to the value. If the 0 is to the right of the last non-zero digit, and what we're saying is at this point, this decimal place is actually significant because it's 0. It's telling me how well close to 0 we can measure, what fraction of 1 that we can measure to. And that's the difference, and it's hard. And I'm not saying this is easy. This can be difficult because if it's on the number on the top, these things are holding place. Even though they're in between the decimal place and the 2, it's not really telling us how well or how precise the measurement is. The 205 is. And we're going to talk about scientific notation later because if we're writing scientific notation, these go away, but this one doesn't. So something to remember. So we go into this one. If the zeros are between 2 other digits, it's important, it's significant. 502, this 0 is significant. 0.2506, this is significant. So those 4 numbers less than 1. And that's the important part of this, is how you deal with zeros that kind of that can be written anywhere. All right, for numbers greater than 1, if the 0 is to the right of the last digit and left of the decimal place, it may be understood, it may be not. So, if we say the decimals here, these 3 can be insignificant. But however, this can be misleading. It can be misleading, and this is why it can be so confusing. And if you have a question on a test, you can say, Dr. Bailey, how many digits? And I'll say, oh, I screwed up. Because here's the thing. With this example, I have a scale that measures to the ones place. If I have over 100 pounds, I have 3 significant figures. So last week I weighed 214 pounds. I lied, but anyway, that's a good number. So I lost 4 pounds, and this week I'll weigh 210. Question is, how many significant digits do I have? Well, here I have 3, 2, 1, and 4. But by by the rules, I should have 2. But that actually is incorrect because I know I have this 0 is actually significant because if I gained a pound, it'd be 211, all 3 numbers are significant. So this is actually a significant value. And this is what can drive students a little bit crazy. So the actual value is 3. Now, when we're looking at these, now we got to apply this method of significant figures. And so we'll go for the easy side first. Multiplication and division. Both have the same rules. When you're multiplying or dividing measured quantities, the answer will have the same number of significant digits as the value of the least number of significant figures. And everybody's like going, huh? What that? I don't know what that means. So we have 2 numbers here, 2.4 and 2,000. 2.4 has 2 digits. This only has 1. So 2,000 times 2.4, you get 4,800. We round to 5 because of only 1 digit. This has some uncertainty to it. It could be 8, it could be 9, or it could be 7. So we round to the next digit because we know this is certain, this is significant, so we get 5,000. So we're rounding. I'll put this here. 5 and higher. Round up. Round the next digit up. Uh, 4 and lower. Keep the next digit same. So those are the 2 things of rounding. 2,000, if it's a 5 and above, round up. If it's 4 or lower, you just keep it where it is. And that's the next digit. Now here's the thing, when we're working with these type of values, is that rounding can have more than one method, and we're just going to keep this simple. So we'll have some examples on this a little later on another slide, on another movie. So we're doing addition and subtraction of significant figures. So when adding and subtracting quantities, the answer should be rounded to the number to the lowest place of value. In other words, that has the So let's look at this. 310. Now this is I'm going to do 311 and 25. We don't round yet because this is if this is non-significant, yes, it'd be 340 or it'd be 336 if we have a 1 there. It depends on the uncertainty of this. This is kind of a better example, 42.5 minus 5.55. You know she gets 36.5.45. 0.95. Somebody messed up the math. That's 5, that's 9. 0.95, and this actually becomes, oops, I forgot the math. It's 37.0 is the answer, not 36. Whoops, sorry about that. I had no idea what I was looking at. That's embarrassing. All right, scientific notation. What we do with scientific notation, you take a small or a large number and state it usefully. the number must be between 1 and 10, and followed by a power of 10. So we're talking about a number that, 3 times 10 to the, say, third. This is one number, one value. All right, so you're taking 3 and you multiply it by 3 tens or by 1,000. So 3 followed by 3 zeros. We got 3.1. Now we got two values. 10 times 10 to the third is the same thing as saying 1 times 10 to the fourth. So it can't be 10. And it can't be a number less than 1. 0.9 times 10 to the third is the same thing as writing 9 times 10 to the second. So the number was between 1 and 10. No decimal, nothing less than 1 and nothing higher than 10. So how we work on this is that we have a large number. It's this large. You find the decimal and you just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I moved over 13 decimal places to the left. So the decimal point is in between the 1 and the 2. So it'd be 1.25 times 10 to the 13th. This is another way to write this. And we used to do this for several reasons. One, we're telling you that all these zeros are insignificant. And two, this can be a lot easier to write than this in a print journal. So there's two reasons. This one is probably the most, to make sure that when we're looking at data, say, these are really insignificant. This is my last value. All the zeros are holding place. We don't care about them. Well, yeah, we do. But anyway, this is why we use scientific notation, because we can easily tell how many significant figures we have. 3 compared to 16. Or 15. So this is what we do. So again, if it's a big number, we move the decimal to the left. We're putting 13, moving the decimal point 13 to the right, if you see this, to make it regular. If we have a small number, 0.00025, you take the decimal and you go to the right. 1, 2, 3, 4, 5. So we move 5 to the right. So it'll be 2.15 times 10 to the -5th. So when we're moving decimal places to the right, we go in the negative direction, so this factor is -5. This is what we mean by scientific notation. Again, this is all one number. And we've got a couple of examples on the next slide, and we'll handle that with the next set of videos. Thank you, guys.